Okay, this screencast is going to cover how to write names and formulas for transition metal, I should say for ionic compounds containing transition metals. Right, so at the end of the screencast, you should be able to, given the name, write the formula for binary ionic compounds containing transition metals, or given the formula, write the name for binary ionic compounds containing transition metals. Oh, sorry. All right, so let's just review. What is the name and formula for the compound that forms between lithium and sulfur? You should be able to, from the periodic table, remember or find that lithium forms a +1, sulfur will form a -2 ion, so my formula will be Li2S, and we would call this lithium sulfide. Metal cation is just the name of the element. For the anion, we're going to use the root plus IDE. So second example, magnesium forms a +2. Nitrogen forms a -3 nitride ion. The name would be magnesium nitride. And hopefully that is what we just did. So we're good. All right, so now just continuing, how would we do the same thing for a formula for the compound? I should say formula and name. For the formula, I'm sorry, what's the okay, let's do, let's do a little warm up here. Continuing this, what is the formula? And we'll say and name. That should be an N. For the compound that forms between iron and oxygen. Iron is Fe, oxygen is O. Looking at a periodic table, we see, whoa. So looking at the periodic table, we find iron here. That's not one of the ones that we know what the number of valence electrons. We don't know the charge. Oh, well, we know oxygen, right? Here's where we're going to talk about what happens to when we have to work with these transition metals. The thing about transition metals is they can have several ions that are stable. For instance, iron can be either a +2 or a +3. We have to, in order for us to tell what charge that metal ion has, we have to come up with a new system. Well, we're not going to. We're just going to use what other people came up with. But anyway, because we can't tell just by saying iron and oxygen what the charge is on the iron, we are going to have to use what is called the stock system, okay, which uses Roman numerals. So we're going to use Roman numerals to tell us what the charge of the cation is. Then, once we know those Roman numerals, we can tell what the charge of the cation is, and then we're going to know the anion because that's going to be the nonmetals. They're all in the groups that we can tell what the stable charge is, and then we're going to adjust the subscripts so that the charges cancel because we remember that ionic compounds are neutral. So what does a name look like? It looks like this. So the name here, copper 1 nitride. This is your Roman numeral. If you don't remember, Roman numerals go 1, 2, 3, 4, that's a V, 5, 6, 7. I don't think we need to go above 7. So those are your Roman numerals. You need to know those, right? So the fact that it tells us it's a copper 1 nitride, this Roman numeral tells me that the charge on that copper ion is a +1. Nitrogen, we know from the periodic table, is a -3. In order to make a neutral ionic compound, I would have to have 3 copper 1 ions and 1 nitride ion. Copper also forms a copper 2 ion. So a copper 2 would have a +2 charge. That's a U, not an A. So copper 2 nitride would again use the nitride ion. And writing a formula using those 2 ions that would be neutral, I would need 3 copper 2 ions for every 2 nitride ions. Okay. So how do we go backwards? What if we're given the formula and we're asked to write the name? You have to include the Roman numeral when you're writing the name for transition metal containing ionic compounds. So we're going to use the charge on the nonmetal, because again, we're going to get that from the periodic table, and we're going to kind of back calculate the charge on the metal. Once we find the charge on each individual metal, we can determine what the Roman numeral is. So let's run through an example. What I like to do, we have this iron and oxygen. So I like to write it iron, oxygen. And I kind of split the idea that the ionic compound so that I have the positive metal cation on the front and the negative anion on the other side. I have 1 oxide ion. Each of those has a -2 charge. So it's a total -2 on the negative side. If this ionic compound is neutral, that means this side has to be +2, right? So these two, because neutral ionic compound. How many iron ions do I have? I only have 1. So that charge has to be +2. So the cation here will be an iron with a +2 charge. The anion is an oxide ion. I would call this, I don't think I can fit it in here, but it's going to be an iron 2 oxide. Now let's look at this compound. I have Fe2 and O3. Again, splitting up the positive and the negative side. I know what the negative is, charge-wise, because it's an oxide ion. I have 3 of them. Each one is a -2. That makes this a total of a -6 on the negative side. I know that this ionic compound has to be neutral, so the positive side has to be +6. I have 2 iron ions. What does the charge have to be on each iron ion so that when I multiply it by 2, I get +6? Well, this has to be +3. So that means I have an iron +3 ion. My oxide is still -2. I'm going to have an iron 3 oxide is going to be the name of the compound. Okay. So you start on the negative side and you work your way back to the positive charge on the metal ion. Please remember, this is only for transition metals that can have more than 1 charge. Remember, zinc is always a +2, silver is always a +1. You don't use Roman numerals for these 2. Transition, they're in the transition part, all right? Don't use Roman numerals. You don't use Roman numerals for the main group metal ions, the ones that always have just the same charge. If you do, you are incorrect. So that's what we had. So practice. I would pause the screencast and make sure that you can write the correct formula. Oops.